Understanding autism. In this micro unit, we are going to answer three big questions. First, what is autism? Second, why do we call it the autism spectrum? And finally, what challenges might autistic students face in the classroom? Before we dig into these questions, let's take a look at the prevalence of autism. The CDC has high quality data on the number of children diagnosed with autism from 2000 to 2014. Over that period, the number of diagnoses increased dramatically from 6.7 per 1,000 children to nearly 17. In slightly different terms, incidence rose from 1 in 150 to 1 in 59, a 250% increase over 14 years. Why such a dramatic increase? There are many arguments and theories that seek to explain it, but the most significant factor is a greater awareness of autism and greater access to resources that lead to a diagnosis. So, what is autism? The American Psychological Association categorizes autism as a neurodevelopmental disorder. In the 5th edition of the APA's Diagnostic and Statistical Manual, or DSM-5, there are three major criteria for assigning a diagnosis of autism spectrum disorder. First, the individual must have persistent deficits in social communication and social interaction. Second, there must be evidence of restricted and repetitive patterns of behavior, interests, and activities. Third, because autism is developmental in nature and not something that can be acquired, those symptoms must be present in the early developmental period. Most autistic children show signs of autism between the ages of 12 and 18 months, but most are not diagnosed until age 3. To meet the criteria for social communication and interaction, there must be deficits in all of the following areas. The DSM uses highly clinical and technical language to describe these social aspects of autism. They are more commonly discussed as a triad of social challenges. Social communication refers to all of the tools we use to understand and interact with others. This includes pragmatic language, the words we say, how we say them, and when we say them. But social communication also includes the ways we use our body to convey meaning, like hand gestures, facial expressions, and eye contact. Social awareness refers to the ability to read an environment and adjust our behavior to match its norms, rules, and expectations. It also refers to the ability to maintain reciprocal relationships or conversations. Reciprocity in social situations requires observing and making inferences about the behavior of others and responding accordingly. Social imagination is in part the ability to make accurate predictions about social interactions. This requires being able to see a situation from multiple perspectives. Another aspect of social imagination is engaging with others on their terms. For example, supporting friends and family sometimes means attending an event because it's important to them, even if we don't really want to. Although these are considered core social challenges, they do not impact all autistic people in the same way. The other key criteria is restricted, repetitive patterns of behavior, interest, or activities. Individuals must have deficits in 2 of these 4 areas. We'll discuss these concepts in greater detail in a bit, but using slightly different terms. It's important to remember that a diagnosis requires deficits in only 2 of the 4 areas. Again, this variation in the diagnostic criteria hints at the tremendous diversity we see among autistic individuals. This is why Dr. Stephen Shore is so often quoted when discussing the autism spectrum. If you've met one person with autism, you've met one person with autism. Why do we call it the autism spectrum? The levels of severity described in the DSM align with how we tend to think about autism. We imagine that each individual is placed on the spectrum based on how bad their symptoms are in comparison to all other autistic people. This is not really a spectrum in the truest sense of the word. Instead, it's a color gradient. Individuals on the left side are more autistic or low functioning, and those on the right are less autistic or higher functioning. The left side we associate with intellectual disability and an inability to speak. The right side we associate with quirks, awkwardness, and special abilities or intelligence. Following this logic, we could choose a shade of autism for each individual we encounter. Those with a lighter shade will have less severe symptoms in all areas we associate with autism. Those with a darker shade will have more severe symptoms. To be clear, there are tremendous differences between individuals on the spectrum. However, viewing the spectrum as a gradient of severity does not align with what we know about the multitude of ways autism manifests and impacts each individual. It leads us to minimize the challenges that high-functioning individuals experience. At the same time, it can lead us to make troubling assumptions about the abilities of low-functioning individuals. So instead of thinking about autism as a color gradient, we should think of it as a true spectrum, the visible light spectrum. The perspective I am describing here is adapted from C.L. Lynch's article, "It's a Spectrum Doesn't Mean What You Think." C.L. is an autistic author and writer, and I highly recommend reading the full article. For C.L.'s metaphor to work, we have to discard the idea that we can understand autism by assigning shades of severity. Take a look at the visible spectrum. It organizes the electromagnetic waves that are visible to the human eye. This arrangement of the spectral colors does help us determine that red light is produced by longer waves than violet. But to the naked eye, deep reds and deep violets are often indistinguishable, even though they are at opposite ends of the spectrum. We can draw a line to indicate where green ends and blue begins, but where we put that line will be arbitrary. Pointing to a specific wavelength doesn't help us to sort out the differences in how humans perceive color. Not to mention, it doesn't make sense to say that red is more colorful than violet, or yellow is less on the spectrum than blue. It's not how we actually think about or perceive color. We think about color in context, how an environment, objects, and light waves from across a spectrum interact to produce an effect we can see and feel. We should think about autism in much the same way. Just as all of the light we see is made up of a mix of waves from across a spectrum, every autistic person is impacted, in some way, by a spectrum of 7 traits. Each individual's color palette shouldn't be summarized as a shade or hue for the purpose of comparing all autistic people. That makes no more sense than saying green is more spectrum than yellow. Instead, these palettes are a unique mix of spectral colors. They capture the differences of each individual and the challenges they face in pursuit of their goals. Let's take a look at the spectrum of traits associated with autism from this alternative perspective. We've already discussed pragmatic language and social awareness in the context of the triad of social challenges. Monotropic mindset refers to the tendency to focus attention narrowly. Someone with a monotropic mindset may hyper-focus on a few stimuli in an environment. They may also have a very narrow set of interests or activities. Monotropism certainly has its disadvantages. Focusing only on a few details comes at the expense of seeing the big picture. But monotropism is also associated with the development of expertise, the precise attention to detail valued in many fields, and the flow states that productivity gurus love to rave about. Information processing is a huge idea. In fact, information processing theory is at the core of cognitive psychology. At the risk of oversimplifying decades of research, information processing is our ability to assimilate and apply new information. The speed with which we do this has all kinds of implications, including how we understand and then adapt to new environments. We probably shouldn't associate speed with intelligence, but we often do. Students with autism may need more time or more exposures in order to integrate and apply new information, but we should not mistake this for an inability to learn or a lack of intelligence. Difficulties adapting to and transitioning between environments can be the result of an interaction between monotropism and processing information slowly. For example, imagine you are asked to watch a movie to prepare for a class discussion. Unlike your classmates, you must watch the movie at double speed. In addition, you're only allowed to see 1/4 of the screen. To comprehend the movie and prepare for the discussion, you would have to make a lot of inferences. Many of those inferences will be very different from the inferences your peers make. Some of them will be very wrong. Feeling lost and frustrated in the class discussion about the movie is not unlike how many students with autism may feel in new environments. Sensory processing refers to how we interpret and integrate the stimuli we receive through our major sensory systems. This includes the ability to tune out some sensory inputs and tune in to others. Everyone has sensory sensitivities. We can all think of particular sounds, smells, or textures we find hard to tolerate. Autism is often associated with sensory extremes. Difficulty sensing or attending to some stimuli while others are perceived so intensely that they are hard to ignore, or at worst, can be completely overwhelming. Repetitive behaviors are often referred to as stims. Autistic people often describe stimming as a way to cope with an uncomfortable environment and regulate their emotions. If you want to learn more about stimming, you can follow the link below to a video from Amethyst Shaber's Ask an Autistic series. Repetitive behaviors may also manifest as the creation and adherence to a rigid schedule and routine. For some, the uncertainty created when a routine is broken can feel catastrophic and unmanageable. Neuromotor differences is another giant topic, but in the simplest term, it's our brain's ability to control our body. Everything from using our tongue to articulate sounds to navigating a crowded room requires that our brain and nervous system sync with our environment. Some autistics have motor differences that prevent them from speaking or walking or both. Others may struggle only with fine motor tasks like handwriting or tying shoes. To get an even better sense of these traits, let's look at a few cases. Tina's palette includes lots of violet and blue. Although she is a good reader with strong language skills, reading social situations and knowing what to say is a real challenge. Tina wants to be a chemist, but she finds working with her peers during long chemistry labs confusing and exhausting. Managing her time is difficult. She has a tendency to hyper-focus. She'll pick up a novel by an author she loves, and before she knows it, it's 1 a.m., and her lab prep isn't done yet. Earlier in the semester, she didn't submit a lab report on time because she spent several hours trying to get the formatting of her report just right. Unlike Tina, Gene's neuromotor differences impact his speech. He relies on text-to-speech software to communicate orally. Until he was taught to type, most assumed he had an intellectual disability. Those who communicate with him now know differently. He can clearly express his needs and carries on rich and witty conversations with his friends and family. But new situations or people are often incredibly difficult. Small changes in his routine, certain sounds, or even an unexpected hand on the shoulder can completely overwhelm him. Gene's difficulty in new situations means that he prefers a very rigid routine in which he knows what to expect every day. Like Tina, Louise's palette includes lots of blue and violet, but Louise has none of the same neuromotor challenges as Gene. She plays intramural soccer twice a week and likes to go for long runs after a stressful day. Although she makes friends quite easily and seeks out new experiences, she has few long-term friendships. Even small disagreements with her friends can lead her to cut off contact completely. At times, she can't understand why her friends are upset by some of her behavior. Gene and Louise are similar when it comes to monotropic mindset. Louise often gets fixated on details or ruminates on bad experiences. At times, she gets explosively angry when her friends or family try to help her get unstuck. Louise, Gene, and Tina are all quite different, but they are all autistic. If you hang a prism in a window, it will refract sunlight into rainbows. None will be exactly the same, but they're all produced by the same spectrum of waves, and they're definitely all rainbows. Comparing their rainbowness isn't nearly as important or interesting as looking closely and seeing the differences in each. What challenges might autistic students face in the classroom? The estimates of co-occurrence of ADHD and autism range from 40 to 80%. Whether or not they meet the diagnostic criteria for both, EF challenges are incredibly common among autistic students. Working memory, cognitive flexibility, and planning are among the most common executive function difficulties associated with autism. However, students with autism as a group show global deficits in all areas of EF when compared to their typical same-aged peers. This is in part due to the developmental nature of autism. There is strong evidence that, like in ADHD, brain maturation is delayed when compared to their typical peers. This is particularly true in the prefrontal cortex, the area of the brain most closely linked to EF. It's not that the brains of autistic students won't or can't mature, it's just a longer timeline. A good rule of thumb is, in terms of their EF development, autistic students are closer to a student 2/3 their age than they are to their peers. So an 18-year-old autistic student may have EF skills in some areas, that more resemble the skills of a 12-year-old. However, we should also keep in mind that an unevenness in skills and ability is a hallmark of autism. In a 2009 study, over 70% of autistic students had an unexpected peak or dip in one academic area. In other words, it's incredibly common for autistic students to have an uneven profile. When we see high-level math skills or below-average reading skills in autistic students, we should absolutely not assume that skills in other areas are commensurate. This is true for neurotypical students as well, but to an even greater extent for autistic students. Weak central coherence emerged as an explanatory theory of autism over 20 years ago. It was thought that the challenges associated with autism were related to a specific deficit in information processing, in which an overemphasis on local information led to a failure to find coherent or global meaning. To illustrate the differences between local and global processing, look at these images. What letters do you see? If we process globally, our answers would be H and F. If we're processing locally, our answers would be F and L. This is a simple demonstration, but it's not hard to imagine any number of academic tasks that require switching between these modes of processing. In some cases, lots of details have to be ignored entirely in order to understand the big picture. Like all of the cognitive theories of autism, weak central coherence does not explain autism. But it is useful to understand that autistic students may have a disinclination towards global processing. The opposite is true, in general, for non-autistics. However, what we have learned is that autistic students aren't locked into local processing. When prompted to process information globally, they do. So, in the classroom, being explicit about learning goals and instructions can help ensure that all students understand where their focus should be and why course content is important. We can also model the practices we want students to engage in so that they understand how instructions fit together into a cohesive process. Finally, it's imperative that we remember that learning is inherently social. We can return to the triad of social challenges to help us understand how the social components of learning may impact autistic students. The list on this slide is far from exhaustive, and as we know, it's not safe to assume every autistic student will be challenged by the same things. Not to mention, the social demands of every classroom are different. However, thinking about learning environments in terms of the skills related to each of these areas is an excellent way to anticipate and support the needs of autistic students. Every autistic student will find your classroom or your school challenging in some way. Before responding to their behavior, we should make the effort to understand their actions from their perspective. Remember, they are trying to navigate social and learning environments designed for someone else's brain.